Good morning, students. Today, let us see the topics weighted graph, minimal spanning tree, and Kruskal algorithm in order to find a minimal spanning tree. Now, the definition of weighted graph. A weighted graph is a graph in which some weight is assigned to each edge of the graph. In the example, the edge AB is assigned to weight 1, BC is assigned to weight 2, and CD is assigned to weight 3, and DA is assigned to weight 4. Okay, so a weighted graph is a graph in which each edge is assigned to some weight or some positive integer. Such a graph is called weighted graph. Now let us see the other definition: minimal spanning tree. Okay, so minimal spanning tree. A weighted graph is said to be minimal spanning tree if it is a spanning tree and also the sum of weights of edges is minimum. Okay. So a weighted graph is said to be minimal spanning tree if it is a spanning tree and the sum of weights of edges is minimum. Okay. Then we know what is the meaning of weight of an edge. Then let us recall what is the meaning of spanning tree. Okay, a subgraph is said to be spanning tree if it contains all the vertices of the main graph and if it is itself a tree. Okay, let us recall the definition of spanning tree. A spanning tree is a subgraph where it contains all the vertices of the main graph and it is itself a tree. Now let us see what is the definition of a tree. Okay, so a tree is a graph which do not contain cycles and each pair of vertices are connected. Okay, so let us recall the definition of tree. A tree is a connected graph where it does not contain cycle. Okay, cycle means it does not contain closed loops, and the meaning of connected graph is every pair of vertices must be connected by a path. The meaning of connected means the meaning of connected is every pair of vertices must be connected by a path. Okay, so now let us see the meaning of minimal spanning tree. Okay, a weighted graph is said to be minimal spanning tree if it is a spanning tree and the sum of weights of edges is minimum. Okay, and the meaning of spanning tree is a subgraph where a spanning tree is a subgraph where it is itself a tree and it has all the vertices of the main graph, and a tree is a connected graph which do not contain cycles. Okay, now let us write the minimal spanning tree for the above example. Consider the previous example, ABCD graph. Okay. Now we want to find minimal spanning tree for the above example. Okay. So in order to find the minimal spanning tree, the output must be a spanning tree, and in the output, the sum of the weights of the edges must be minimum. These two conditions must be satisfied. Okay, so in order to write the minimal spanning tree, I have taken the vertices first. The vertices are A, B, C, D. Okay, then I have started with edge AB, and I have also denoted the weight of edge AB as 1. Then I have taken edge BC and I have also shown the weight 2. Then I have taken edge CD. Then I have shown the weight 3. Okay. So I conclude that this graph is the new graph is the minimal spanning tree because uh, you need to check whether it is a spanning tree or not. In order to see whether it is a spanning tree or not, it should contain all the vertices of the main graph. So main graph is having vertices A, B, C, D. The answer is also having the vertices A, B, C, D. Okay. Then the other point is it must be a tree. Okay, it must be a tree. That means it should not contain any cycles. Okay, the new graph has no cycles. That is, it has no closed loops. Okay, and it should be connected. It means every pair of vertices must have a path. In the new graph, every pair of vertices is definitely having a path. Hence, it is a spanning tree with and it is having all the vertices as of the main graph. Hence, it is the minimal spanning tree, and the sum of the weights of the edges in the new graph is 1 plus 2 plus 3 and it is 6. Okay, so once again see the definition of minimal spanning tree. A minimal spanning tree is a weighted graph where it is itself a spanning tree and the sum of weights of the edges is minimum. Okay, so weight of an edge means some positive integer assigned to the edge. Then the meaning of spanning tree is it should contain all the vertices as that of main graph, and it itself, it must be a tree itself. Tree means it must be connected and it should not contain any cycles. Okay, now let us see Kruskal algorithm in order to find minimal spanning tree for a given graph. How to find minimal spanning tree? How to find minimal spanning tree for the given weighted graph using Kruskal algorithm. Okay, so now let us see the steps involved in the Kruskal algorithm. Okay, so you will be given a weighted graph where each edge is assigned to some weight, and you need to find minimal spanning tree for the given weighted graph. Okay, so the procedure says first you need to consider all the vertices. So what are the vertices available in the weighted graph? You consider all the vertices. Okay, you consider all the vertices. Okay, then the second point is the second point is let us start with a minimum weight. Let us start with a minimum weight and join the edges with the minimum weight to maximum weight. Okay, then the last point, so repeat the point step 2 until every pair of vertices are connected. Until every pair of vertices are connected. Okay, so Kruskal algorithm says first you need to take all the vertices. Then the second point says that you need to start with a minimum weighted edge. Then start with a minimum weighted edge and move on to maximum weighted edge. Okay, then repeat step 2 until every pair of vertices are connected. That is, every pair of vertices are having paths. Okay. Now let us see the example. I have taken an example. Okay. So there are vertices A, B, C, D, E, F, G. These are all vertices, and the corresponding weights are also shown in the figure. Okay, now we need to find the corresponding minimal spanning tree by using Kruskal algorithm. Okay, so a minimal spanning tree, the meaning of minimal spanning tree, it must be a weighted graph, it must be a spanning tree. Okay, then and the sum of weights of edges must be minimum. If all the three are satisfied, then it is called a minimal spanning tree. It must be a weighted graph, it must be a spanning tree, and the sum of weights of edges must be minimum. If all the three are satisfied, then it is called a minimum spanning tree. Now we are finding minimal spanning tree with the help of Kruskal algorithm. Okay, so I have taken the main weighted graph, then I have spotted, then I have shown only the vertices. I have taken only the vertices. Okay, so the last one is the immediate step of the given graph. I have taken only the vertices. Then I have started with minimum weights. Okay, I have started with the minimum weight. The minimum weight is 1. So in the middle figure I have shown the minimum weights. In the middle figure I have shown edges with the minimum weight. Then I have continued the process and connected the other edges. Okay, so then I have taken, in the next step I have taken the next edge with the minimum weight. I have taken edge with weight 2. Okay, then I have taken, then if I have taken B edge. If I have taken B edge, then it will be a cycle. So I have not taken edge B. Okay. Then I have taken weights edge with weight 4. I have taken edge with weight 4. Okay. If I have taken AD, then it will be a cycle. So I have not taken edge AD. Then finally I have taken edge with weight 6. Okay, so the last graph is the required minimal spanning tree. Okay, the Kruskal algorithm says let us denote all the vertices first. Then let us start taking edges with the minimum weight. So I have started with the edge having weight 1. Okay, then I have moved on to edge with weight 2. Okay, so then if I have taken BE edge, if I have taken BE edge, then it will be a cycle. So I have not considered the edge BE. Then I have taken the edge with weight 4 as shown in this graph. Okay, in the middle graph. Then if I have taken EAF edge, then again it will be a cycle. So I have not taken AF, and finally I have taken GC edge, that is with weight 6. So this is the required minimal spanning tree. The procedure is first denote all the vertices, then join the vertices with minimum weights to maximum height. In the process, it should not contain any cycles, and stop the process stop the process if all the vertices are connected, that is all the vertices are having paths. Okay, so this is the final graph is the minimal spanning tree, and minimum weight of the edges is 1 plus 1 plus 2 plus 2 plus 4 plus 6, and it is 16. Okay, now let us take another example. In order to find minimal spanning tree by using the Kruskal algorithm. Okay, so in the new example, the vertices are A, B, C, D, E, F, G. These are all vertices. So I have started with the vertices. First, I have taken the vertices. The vertices are A, B, C, D, E, F, G. Okay. So according to Kruskal algorithm, first you need to start with the edges of minimum weight. You need to start taking edges of minimum weight. Here, the minimum weighted edges are DC is one edge, and the other edge is EF. Okay. So first denote the vertices, then start taking edges with minimum weight. First I have taken edge with weight 1, then in the next step I have taken edge with weight 2. Okay, so I have shown AB and BC. Okay, then I have taken edge CF with weight 3. Okay, okay, so in the process it should not contain any cycles. Okay, then I need to take if I have taken edge CE, then it will be a cycle. So I have not taken edge CE, and the final graph is shown in the last figure. So it is the minimal spanning tree because it is the spanning tree. It is the weighted graph, and the sum of weights of the edges is minimum. So this is the spanning tree. The final graph is the spanning tree because it contains all the vertices, and it is itself a tree. Okay, tree means it should not contain any cycles. It does not have any cycles. Okay, and also it does not have any cycles, and also it must be connected. Okay, in the graph you can see that every pair of edges are connected, and the minimum weights of the edges is 1 plus 1 plus 2 plus 2 plus 3 plus 5, and it is 14. Okay, now let us see another example. You solve this example. In the next weighted graph, the weights are 5, 4, 3, 4, 2, 4, 6, 2, and so on. The vertices are A, B, C, D, E, F, G, H, I. Okay, so we have seen what is weighted graph, then what is minimal spanning tree, then how to find minimal spanning tree with the help of Kruskal algorithm. Okay, so the steps of Kruskal algorithm are: first you need to denote all the vertices, then you need to join the edges with the minimum weights to maximum weights. So you need to take all the vertices, then you need to join the edges. You need to join the vertices with the minimum weights to maximum weights. Okay, in the process it should not have any cycles, and you need to continue the process until every pair of edges are connected, so that it will be a spanning tree. Okay, and it will be minimal spanning tree. Okay, thank you.